My name is Anna Kavanaugh, and I currently teach at Desert Willow Elementary School, and I'm serving on Vail's Technology Advisory Team and Curriculum Management Team. Super excited today to get to share with you about the computational thinking process and how we can use this in all areas of our curriculum. My goals for you by the end of this video are for you to be able to identify and explain the steps in computational thinking, then take this process and apply it to your grade level in all areas of the curriculum, and lastly, being able to understand the benefit of using computational thinking and why it's something important for you to use and how it's going to help you and your students. Throughout the video, I will talk about the standard and how it relates to our Arizona EdTech standards. Then I'll dive into what the process looks like. And then lastly, I'll offer up a couple opportunities for you and your students to use to practice this process in the classroom. Taking a look at our Arizona EdTech standard, it is Standard 5, Computational Thinker. Now, what the standard says is students develop and employ strategies for understanding and solving problems in ways that leverage the power of technological methods to develop and test solutions. Now, it's a little bit wordy, but the thing we want to focus on within this standard is the line about solving problems. Computational thinking is a problem-solving skill set. Now, a common misconception with this standard is that it can only be done and only be practiced in math and in technology. Hopefully, by the end of this presentation, you will start to see how this is something we can use in all areas of our curriculum. So, computational thinking is the process of thinking through a problem step by step. It's not just following a list of directions, but it's a whole new skill set that helps students think about the process of solving a problem. It's something that they should be able to, and we want them to be able to, copy and paste this skill set into any new problem that they're trying to face and be successful in solving that issue. Now, we can decompose computational thinking down into 4 simpler skills: decomposition, pattern recognition, abstraction, and algorithm. Computational thinking is something that happens everywhere, and it's something you're probably already doing with your students without even realizing it. But by being intentional and using a common language and giving explicit instruction on how to use this process, students will be able to adapt to new ways of thinking and strategizing when it comes to problem solving. It's something that they should be able to use anytime they face a new problem. Now, this is something that we see in Legos or in cooking. And today, we're going to compare it to making lasagna. We'll use that as our example to understand what these steps look like in action. So the first step is decomposition. Now, whenever you make a lasagna for the first time, this is a really big task. So in order to make it less intimidating, we decompose this project into smaller steps. In cooking, we call it a recipe. So you can think of decomposition as figuring out the recipe on how to solve a problem. Ways to practice this and model this with your students in your class: you can talk about or decompose the different parts of a sentence. Instead of telling your students, write a sentence, what are the parts of a sentence? What does it need to include? You can break this down into smaller steps to make this a more approachable task for your students. In looking at upper grades, I know I teach 4th grade right now, and I taught making inferences a few weeks ago, and this is a really abstract concept for students to understand. So by breaking it down into steps for them to follow in order to get this end product of making your inference, it was a lot more approachable and comprehensible by my students. With looking more at K2 when you're teaching how to read, segmenting is a big thing that you do when we're breaking those words down. You don't give them a 3-syllable word and say, read this. We start with 3-letter words and break it down by sounds. Then as they get older, we break it down by syllables to help them, again, have this big task be broken into simpler steps that they can use to get their end product and solve their problem. Looking at science, we can think of decomposing when we're talking about photosynthesis or the parts of a cell, or a few weeks ago I taught characteristics of rocks, and I was never very good at geology. That was never my strongest subject, but by breaking down the characteristics and the ways that they were made it a lot easier for my students to be able to identify the kinds of rocks because they were able to look at it in a smaller way and not just see this whole intimidating project. Relating it to some of our specials that we have in music, We break down all of the different pieces. You're working on the notes, the rhythms, the dynamics, the accents, all of those different pieces that are working together to make the whole piece of music. But we would never ask a student or expect even a grown up to sit down and play the entire thing perfectly. It has to be a process. There are steps that go into making it or helping you be successful in playing that piece of music. In art, it can be laying out the steps for a project, and in PE, just laying out the steps for or giving the directions for a game. Instead of saying, go play soccer, tell them all the steps for what playing soccer looks like. I want you to stop and think for a minute of one standard that you're teaching right now. First, how are you already decomposing this skill for your students? And then, secondly, how could you decompose it further? The next step in the computational thinking process is pattern recognition. This is just being able to identify patterns or similarities within the decomposed task or problem, which allows us to handle this problem a little more efficiently. So, with making lasagna, you are building layers of pasta, sauce, cheese, a couple different times. This is a pattern that we can recognize. Taking this into your classroom, a big one for ELA is spelling patterns. We do that across all the grades with working on reading and writing and just spelling in general. But by recognizing these patterns, students will be able to apply what they've learned and what they've seen in a new area. For example, if you were teaching the TION sound, the English language has all kinds of wacky spelling patterns and sounds that are unexpected. So, TION is a really good example of when you see this anywhere you go and recognize the pattern of TION always says shun. When you get to a new word you haven't seen before, but you see that pattern, students will be able to effectively remember the pattern, recall what they've learned, and apply that in this new situation. Taking a look at some upper grades, if you're working on persuasive writing, or I'm teaching text structures right now, focusing on what are the patterns within, what do all description paragraphs have? What do all cause and effect paragraphs have? What are those key features, those patterns that we can see regardless of the topic in all different areas? Again, this is something that needs to be modeled for your students. So with text structures, when I'm talking to them about the different text structures, about description, we can notice that there's always adjectives and there's lots of characteristics. Those are the kinds of pieces that we can help our students focus on and see those patterns that they might not recognize without our guidance to get them there. History has a whole bunch of patterns all across, but two that I want to focus on is thinking about like looking at the patterns within certain civilizations or certain government structures. Because if we teach them the patterns, then when they see a new government structure or we ask them the question, which one is this? They can think back to the patterns that they've learned and think about the things that they're looking for and the key elements that go into creating that government structure, went into making that civilization what it was. In specials, this can be recognizing rhythms and recognizing chords, or just starting to remember that if a note is on the first line, that it's an F in treble clef, just recognizing those patterns to help them be more efficient in solving their problems. In art, this can be understanding what paint you use or what utensils or even what paper you're using, how that impacts what your final project looks like. And in PE, just thinking about and pointing out to your students what kinds of foods make you feel good, what kind make you feel lethargic. Same with what kinds of activities get you going and getting you excited versus what makes you feel more tired. So these are patterns or ways that we can both model for our students and have our students practicing recognizing patterns. Pattern recognition goes hand in hand with our next step of abstraction. Abstraction is the process of filtering out or ignoring unnecessary information to focus on what's important. So in this case, focusing on that pattern that we just recognized in the last step, being able to ignore the things we don't need and hone in on the parts that are really important. So in our last step for lasagna, we recognize the pattern that we're doing the same steps over and over and over again. So since we know that, we don't need to sit there and read every single line of our recipe because we know what the pattern looks like. Which in the long run, this ends up speeding up the process of making our lasagna because we don't have to read each line. We know what we're doing and we can be a lot more efficient in that way. This is the goal of abstraction with all of problem solving is being able to recognize the patterns, focus in on those, and help us to be more efficient in solving our problems. In your classroom, one of the big ones that I think of how you might already be doing this and a good way to help your students practice this skill is helping them with taking notes. Now, I put it under the science category, but it can really be done in any area where you're taking notes. Of course, everything that we as teachers say is important, and our students should remember all of it, but they also should still have the skill set, and we need to teach them the skill set of being able to pull out the important pieces, the key information, and writing down the things that will help them to remember it. It's not that they need to write down every single word that I said, but if they wrote down a couple words that help them remember the story or the information that I gave that day, that is something that is way more beneficial than trying to have them remember every single little thing. And it's helping them to take the information and interpret it in a way that makes sense to them. Looking at abstraction in ELA, a big one with my students right now is anytime I ask them to find evidence or show me how you know, being able to filter through all of the paragraph that they're reading and find the one piece that they need that applies to this question can be a really challenging skill. But if it's something that we're practicing and reminding them of, it's something that they would be able to or should be able to successfully do in order to sift out all that other information and find the answers that they need. An activity that I like to have students do to practice the computational thinking or the abstraction portion of it is giving them a word count with their writing. Because then students are forced to think about what are the important pieces? What do I need to include? What might not be as important if I don't have as many words? Having them really focus in on that important information. Taking a look at specials, when you first look at a piece of music, there's a lot of things going on there. So being able to filter out what do I need to work on right now? What do I need to focus on today to get to my next step of that we laid out before? How can I get there? What are the important pieces that I need to focus on right now? In art, this can be focusing on colors and shapes, forms, textures, depending on the standard that you're teaching. And then in PE, focusing on the goal of the game. What are you trying to accomplish? So abstraction is getting rid of all the unnecessary stuff and being able to focus on what do I actually need right now to be able to effectively solve my problem. I want you to take a second and think back to that same standard you were thinking about earlier that you were decomposing. What are some patterns that are found within that concept? And secondly, how would helping students recognize these patterns and focus on these patterns speed up their problem solving process? The final step of the computational thinking process is algorithmic design. Now, algorithms are just a sequence of instructions or rules created to perform a task. So with our lasagna example, there's already a recipe written out for that, but that's not always the case with every problem that our students are going to try to be solving. So we want to make sure that if we are, and if our students are, putting in all of the hard work to do the decomposition and recognize those patterns and abstract the important information, this step ensures that they're not putting all of that work to waste. They're able to write out, these are all the things that I learned, writing their own recipe at the end from what they've learned through all of these other steps of the process. Algorithmic design in your classroom can be practiced and modeled in all of these areas. Looking again first at ELA, this could be having your students create a poster or a list of rules telling you how do you know which kind of punctuation mark to use. We problem solved that out. We did the direct instruction over it. Now you tell me, how do we do that? Or it can be having them create a poster on Canva over the different elements of poetry. We decompose. What does poetry have? These are the patterns we saw. Now tell me, if I had never ever heard about poems before and the elements of poetry, how would I know? What were the important pieces? What do you need to have? In social studies, this could be creating an animation on Google Slides about the water cycle or making a flowchart that shows the cause and effects of the Stamp Act. And looking at specials, this could be for music, creating a list of how do you sight read a piece of music? And in art, how do you make, what colors should you mix if I wanted to get this particular color that I'm wanting to use? Or in PE, creating a list of rules of what does sportsmanship look like? What are the important pieces for that? So algorithmic design is just taking all of what they learned and being able to then teach that to somebody else. This can be done again by them practicing, and we can be modeling that for our students in the way that we're presenting information to them as well. Now, I've mostly focused on the academics and ways that we can use this process within the academics, but as I mentioned, this is just a problem solving skill set. And that being said, it's something students can use in social situations as well. So, for example, let's say the scenario was there's a group of girls that are getting into arguments every single day at recess. Decomposition would look like identifying who you're having the problems with and maybe where the problems keep occurring. Pattern recognition, after we break apart who are the issues, where are the issues happening, pattern recognition is noticing the types of situations that could typically cause disagreements. So, whether maybe it's the same girl that keeps having the issue, or if it always happens at recess, or if it's always because they can't decide on what game to play, they're able to recognize a pattern. Moving into abstraction, which arguably could be one of the harder ones in this situation, would be deciding if what they're arguing over is actually important. We know abstraction is focusing on the important information. This is their opportunity to assess, does it matter? And should I make it as big of a deal as I'm making it right now? And lastly, again, being for algorithmic design, being able to then teach somebody else or come up with that problem solving steps for next time. They could create steps for how do you have a productive conversation when there's a conflict. So then when they face that issue later, they already have a plan for how they're going to go about solving that issue. And all that being said is exactly why it's so important for us to be practicing this skill with our students, because we are building problem solvers. We want them to be able to go out into the world someday and any problem they face, being able to effectively solve that or get at least get to the other side of it and being able to have a new perspective. So, this process can be used to solve problems inside the classroom and outside of the classroom. And it's something that if we build that common language, we can be intentional about asking them and probing them to get them to where they need to be. Couple ideas of how you could be using this in your classroom and some best practices for this. First, starting with would be to pose questions. Ask lots of questions, open ended questions, not just ones that are going to be like 2 plus 2, that always equals 4, but giving them questions that really make them think and think deeply about how they could solve their problems. Secondly, allowing the students to play with and tinker with a problem. This goes along with the next one, too, of giving them time to work through their ideas and allow them to draw their own conclusions. I know something I struggle with as a teacher is when I see my students struggling with something or not understanding, my reaction is to jump right in and tell them the answer. But we want to give them the time to be wrong so that they can learn and process through, how do I find the right answer? How do I get to where I'm trying to go? And the last one is a little tricky. It's not always something that you can implement, but you want to try it as much as you can. And that's accepting more than one solution to a problem. Now, again, with math, 2 plus 2 is always 4. But as many opportunities and ways that you can find to let your students think about it and find their own solution and find their own answers, it's very beneficial in their thinking process and their problem solving process to know that they can find their own way to get there without being wrong and without us telling them that they have to do it a certain way. Lastly, a couple ideas for ways for you to practice if you want to work. I would invite you to work through at least one of these and be very intentional about thinking through how you're using this process. These are also activities that you could use in your classroom with your students to explicitly explain the process of the computational thinking. You can have them trying them out, and there's some graphic organizers online as well that you can find to help them write out exactly how they're doing each step. But that being said, not every time you're teaching computational thinking, is it going to be a laid out full lesson plan over all of the steps on computational thinking. It is something we can weave into each of our classes and into each of our activities that we're doing to help them continue to practice this in many different ways. But these are a couple ways or a couple activities that you can use for you and your students to try this process out in your classroom. Last thing that I want you to think about a little bit is just why do you think it's important for students to practice the skills of computational thinking? And how can you use the components of computational thinking across different subject areas? Just wanted to leave you off with a couple of resources at the end to, if you wanted to do some more digging into what the computational thinking process looks like or want any of those other activities, those are all be here as well for you to use.